person of mass 60 kilograms is standing in a lift which is of mass 540 kilograms. Okay, so when we look at this lift here, okay, we'll want to think about the masses of the two objects combined. Okay, so I call it an object. We're talking about the lift and the person, yeah? So the lift is 540, person is 60. The combined mass, okay, will be 540 plus 60 will be 600 kilograms. Okay, that's the combined mass. So the combined weight of the lift then will be 600 times G. All right. There's also then tension in the lift cable, okay, which says 6,600 newtons. Okay, so force is measured in newtons, and they say, look, this cable here is pulling up this lift with this amount of tension here. But of course you've got the weight then, which then this would be in newtons as well, because you've got the weight here with the mass times the value of gravity here, okay? And it says that it's accelerating upwards at a constant rate, okay? So accelerating upwards means I'll have the acceleration acting upwards there. So part A then, it says calculate the value, okay, of A. So because we've got forces acting here and there's acceleration, we're going to use Newton's second law, okay, in direction of motion, okay? I always write that down to sort of like understand which way it's actually going, okay, in terms of setting out Newton's second law. So it's going upwards, isn't it? Okay, going upwards. So if it's going upwards, the leading sort of force is this rope, isn't it? That's what's sort of in the front, if you like, yeah, because the lift's going upwards, and this is at the front essentially pulling up the lift. So we've got 6,600 as the sort of leading force, but then you've got a resistance, haven't you? Of course, the lift and the person inside there, the weight of it is pulling down, isn't it? Okay, so it's actually slowing it down, if you like. Yeah, if that person wasn't in there, the lift could potentially go faster, couldn't it? So the combined weight is 600 G. Okay, so you've got 6,600 going up, and then you've got the resistance then of 600 G, equals then to mass times acceleration. Okay, so the mass is 600, the mass of the overall thing, times acceleration. So that's Newton's second law, remember, okay? So, you know, you're familiar with it as like F equals ma, yeah? I prefer to think of it as resultant force equals to ma, okay, equals to mass times acceleration. So rather than thinking as just F, I think of it as like the resultant force. So the resultant force is the overall forces combined. Yes, we've got 6,600 pulling it up, but there's a resistance, isn't there? The weight of it is pulling it down. So that's the overall effect, that's the overall force, okay, creating the motion. So I can work this out then to determine A, because essentially we know G to be 9.8, okay. So it's the case that, again, on my calculator, 6,600 take away 600 times 9.8. So I do that, that comes out to be 720 equals 600 times A. To get A then, of course, you just take that 600 over the other side and divide. So if I do that, I get out 1.2 meters per second squared. Okay, part B then, it says find the reaction between the person and the floor of the lift. So what we need to do now in part B is we can draw another sketch, okay, another diagram, and we're now going to focus on the forces acting on the person, okay, right? We're not looking at the bigger picture now, we're just looking at the actual person, okay, so what forces are acting on this person here? Well, the person has a weight, yes, if I just label the person there as like a dot there, okay, the person has a weight, okay, of 60 kilograms times gravity, so 60 G, okay, that's its weight, and it has a reaction there, okay, so there's a reaction there from the floor keeping that person in the lift, because if if there wasn't a reaction from the floor, that person would just fall straight through the floor. So the floor is strong enough to keep that person there, so it's pushing that person up effectively. Okay, so there's the reaction there. Now we are accelerating upwards, don't forget. Okay, but we know now what the value of A is. We know A is 1.2. So again, using Newton's second law, okay, we've got R going upwards. Take away the weight then, which is 60G. Okay, so all these forces now acting on the person. We're looking at the resultant force acting on the person. So R, the reaction going up, take away the weight, equals then to the mass of the person, okay, which is 60, times then the acceleration, which is 1.2. So you get then this. So R minus then 60 times 9.8, which is 588. 60 times 1.2, which is 72. So we take then 588 over, and we get our answer to be 660 newtons. That's the reaction there on that person.